5.7. Graph linear inequalities in two variables. A linear inequality in two variables just means replacing the equal sign in a linear equation with an inequality. So you can either have the greater than sign, the less than sign, the greater than or equal sign, or the less than or equal sign. And algebraically, we can represent this as ax plus by less than c, or any of the inequality signs. Numerically, an example would be 2x minus 3y less than 6. So the graph of a linear inequality in two variables will be a set of points that represent all solutions of an inequality. So I'm going to use 2x minus 3y less than 6 to explain what the graph of this linear inequality looks like. The first thing you have to do is to draw the boundary line. So I'm going to have to let 2x minus 3y equal to 6. And after you graph this equation, you should get this boundary line. It's dotted because it's a less than sign. Okay, and this boundary line divides this x and y plane into two half planes. And the shaded half plane is the graph of this linear inequality. And all the points in the shaded area will satisfy this statement. So, in other words, all solutions of 2x minus 3y less than 6 lie on one side of the boundary line, which happens to be above this line, this shaded region. Guided practice, graphing linear inequalities. I'm going to take you through this step by step to show you how to graph a linear inequality. So first you have to find the equation of the boundary line by replacing the inequality symbol with an equal sign, and then graph the equation. So here I'm given an inequality, and I'm going to rewrite this inequality as 4y plus 3 equal to 3 times the difference of x minus 2. And then 4y plus 3 equals 3x minus 6. Well, I'm going to put this in standard form because I'm going to use the x and y intercepts to graph. You may choose to change it to the slope intercept form to graph as well. So this will be equal to 3x minus 4y equal to 9. And then my x-intercept will be 9 over 3, so it would be 3. And my y-intercept will be negative 9 over 4, and therefore it's 0, negative 2 and 1/4. And then to graph this boundary line, we need to first figure out if it's a dashed line or a solid line. So we need to look at the inequality again. It's a greater than sign, so we need to use a dashed line. So a dashed line would have dots, which means the solutions do not lie on the dashed line. And a less than sign would also be a dashed line. Solid lines would have to have a equal sign underneath the greater than sign or the less than sign. And the solutions would lie on the line. So for this case, we need to first plot the points. 3, 0, and 0, -2, 4. This is 1, this is -1, and -2, and 1/4 should be about here. And then you draw my dash line. Secondly, we need to test the point 0, 0 to see if it is a solution of the inequality. If the graph is y goes mx, meaning it goes through the point 0, 0, then you have to use a different point. Now for this graph we can use 0, 0. So I'm going to substitute 0 on the left hand side of the inequality. It will be 3, and 0 on the other side. It will be -6. And this is a true statement. So 0, 0 is a solution. Therefore, I'm going to shade everything above the boundary line that includes the point 0, 0. So thirdly, what I just did here, if the point 0, 0 or the tested point is a solution, shade the half plane that contains 0, 0 or the tested point. If not, shade the other half plane. Okay, guided practice continued. Graphing inequalities. So if we graph x less than 3, we need to first write the boundary line, which is x equal to 3. Now this must be a vertical line through x equals to 3. I'm going to count 1, 2, 3. And then because this is a less than sign, I need to use a dashed line. So like this, and then because it's x contains all the values less than 3, we need to shade to the left. And for y greater than or equal to -2, we need to use a solid line, meaning the solution will also lie on the boundary line. Okay, so the boundary line will be y equal to -2, so it's a horizontal line. -1, -2. And it also contains all the y coordinate values above -2. Let me first label this and shade everything. And this would be the solution of the inequality, y greater than or equal to -2. For this inequality, we need to first find the boundary line, and by setting this equal to an equation, and the x-intercept will be 12 divided by 3, which is 4, and the y-intercept will be 12 divided by 4, which is 3, so 0, 3. Okay, and we go ahead and graph because this is a greater than sign, so we need a dashed line. 1, 2, 3, 4, and 1, 2, 3. This is 4, and I'm gonna go ahead and draw this dashed line. Okay, and then I'm going to use 0, 0 to test the point. So this will be 0 plus 0, And apparently 0 is not greater than 12. So 0, 0 is not a solution of this inequality. So we need to shade the other half of the plane. And for this inequality, I'm going to first write 2x minus 5 equal to 3y plus 1. I'm going to again change this to standard form because I think using the intercepts is easier to graph. But again, you can change it to slope-intercept form if you like. And here my x-intercept will be 6 divided by 2, which is 3. Y-intercept, 6 divided by negative 3, which is negative 2. So 3, 0, 0, negative 2. 1, 2, 3. And negative 1, negative 2. And because it's a greater than or equal sign, it should be a solid line. Let me go ahead and draw my line. Okay, I'm going to test my 0, 0. So 2 times 0 minus 5 greater than or equal to 3 times 0 plus 1. So this is negative 5. Apparently, negative 5 is not greater than or equal to 1. This is not a point, so we need to shade the bottom half plane, which does not contain 0, 0. Part B. Write an inequality to represent the graph. So here are the steps. First, you need to write the equation of the boundary line using the slope-intercept form, which is the easiest. And then your inequality can be either of these. Now, for this first case here, it should be either the first one or the second one because it's a dashed line. And then thirdly, you need to test the point not on the boundary line to determine if it's the inequality with the greater than sign or the less than sign. So let's go with the first one. I'm going to begin here to find the slope. I'm going to shift 1 unit down. So that's my change in y. And shift 1 unit to the right. Change in x. So my slope is negative 1. My boundary line will be y equal to negative x. And of course my y-intercept is 0. I don't need to write that. Now my inequality can be either y greater than negative x here, or y less than negative x, this one. So I'm going to test the point. I'm going to use negative 1, 0. So if x is negative 1 and y is 0, then I'm going to get 0 greater than positive 1. And that's not true. So therefore, this cannot be an answer. So if I look at y less than negative x, I substitute 0 in and substitute negative 1 in for x. I get 0 greater than 1, so this is okay. And then my inequality that represents this graph would be y less than negative x. So this would be the answer. For this next graph, again, I know my y-intercept is negative 1. And then I'm going to find my slope. Shift 1 unit up, change in y. Shift 1 unit to the right, change in x. So my slope is positive 1. I'm going to use a slope-intercept form. Y equals mx plus b. So y equals 1x minus 1. So for short, y equals x minus 1 is our boundary line. And this inequality could be y greater than or equal to x minus 1 or y less than x minus 1. And I'm going to use 0, 0 to test. And it seems like for this first inequality, it's true, but we need to double check. And 0 cannot be less than or not equal to negative 1. So therefore, y greater than or equal to x minus 1 will be the inequality that represents this graph. Now for this graph, the boundary line is y equal to negative 3, and it's also solid, so this inequality that represents the graph could either be y less than or equal to negative 3 or y greater than or equal to negative 3. Well, it's because the bottom half of the graph is shaded, we want all the y coordinates that are either negative 3 or smaller. So the answer has to be this first inequality here, y less than or equal to negative 3, and not the other one. Word problem. A tour operator recommends that a river rafter wear a protective suit under the temperature conditions described below. So when the air temperature and the water temperature together is less than 120 degrees Fahrenheit, a protective suit is recommended. And if it falls below less than 100 degrees Fahrenheit, the protective suit will be required. So part A, write an inequality that describes the possible air temperatures and water temperatures for which a protective suit is recommended. So that would just simply be A plus W less than 120. Part B, graph the inequality in part A. Well, I can just first graph A plus W equal to 120, which is the boundary line. So the intercepts will be at 120, 0, and 0, 120. And then we need to test the 0, 0. And it does include the point 0, 0, so we should shade in everything underneath the boundary line. And we also need to make the boundary line dashed. Part C, if the water temperature is 40 degrees Fahrenheit, for which air temperatures is a protective suit recommended? So I'm going to have to take the inequality from part A plus W less than 120, and I have to substitute in the water temperature 40 degree and solve the inequality. And A will be less than 80. So air temperature below 80 degrees Fahrenheit is recommended. Part D. How would you change the graph in Part B in order to describe the situations in which a protective suit is required? Explain. And then draw a new graph in Part B using a different colored pen. Well, first of all, the inequality in which the protective suit is required is A plus W less than 100 degrees Fahrenheit. So then the boundary line will be represented as A plus W equal to 100. So your intercepts will be 100, 0, and 0, 100. Again, it's a dashed line. And then what happened is the graph shifted down by 20 units. See, from 120 to 100. Okay, and this concludes the lesson.